Okay, the project we are talking about today is the first phase of a 4-phase affordable housing development in Huntsville. The building will be 3 stories of 1 and 2 bedroom apartments over a level of parking and constructed from CLT roof, floors and shafts with light wood frame structural panels. The goal of the building is that it will be in service for at least 100 years, is at a minimum net zero ready, built to passive house level of construction, and to be comfortable, desirable long-term homes. The building hasn't been designed by just one person, been designed by a collective input and experience of the client, the community, site constraints, and all of the consultants that have been involved. I was just looking at this earlier, and I think we may have deviated a little bit from, from the second point, but that's okay.
One of the reasons why we were able to explore these questions and was because of the support from FedNor. So I just want to give a shout out to FedNor, who saw the importance of considering the long-term affordability of a building. And yay, FedNor. And we'll talk a bit more about that as well.
And I think for number 1, the key to keeping it affordable is ownership by the Community Land Trust. So just pass it over to Melinda to talk a little bit about how that works.
The Muskoka Community Land Trust started organizing about 10 years ago, and organizing because we really needed a different way of solving our housing affordability problem. And we have a need for not just short-term affordability, but really long-term affordability. And so community volunteers came together and started a not-for-profit organization. And the purpose of a land trust is to hold land for the highest need of the community in perpetuity. So land is no longer a financial asset, it is now a community asset. The land trust model protects that land from being flipped on the market or being taken advantage of from the financial sector. And that gives the opportunity to the not-for-profit organization and its community partners to build housing on that land that can be affordable permanently. And part of making buildings affordable permanently, the community group understood that meant making sure that it can withstand the climate we're going to get, that it can be affordable to heat and cool, and that it can the costs to pay into it, so it has to be affordable to build, but it also has to be affordable to maintain. The operation and maintenance of those buildings have to be affordable. So all of those requirements are part of the Land Trust's value system, and to help build a more sustainable, equitable community. Just like that.
And we are trying to follow a process that is not typical design bid build, where the team members are involved only when they're essential, and then they stay focused solely on their own discipline, and the result is lots of emails, and just everything is really siloed. You may be familiar with integrated project delivery under CCDC 30 contract. It's a relatively new contract type that it's not mainstream yet, but it is gaining traction. So we're trying to get the best of both worlds, of the 2 worlds, and integrate the ethos of the IPD methodology into a more standard contract with an eye on full IPD in the future. It's a very, very different process, which requires a completely different mindset. But the success rate and satisfaction rate is phenomenal from the information that we've had. And we also had a fantastic presentation from Collier's IPD department, which I can't recommend enough to, if it's something that interests you, to have them come and speak to you. It was really good. And it also makes sense for this project, as all of the items in the left column on the screen either align with MCLT's values or they inform the design process. And then a big benefit to having access to the entire project team very early on is the impact it can have on decision making. Next slide, please. Designing a building that is for now and for quite a distance into the future involves a few additional consultants. Melinda will talk about them later, than what we would have in a normal sort of traditional project. As we're considering future climate projections, the total cost of building and generating data for things like energy efficiency and embodied carbon. And then this adds an extra level of complexity to decision making. So where a typical project is oftentimes purely cost-driven, so if you have a cheaper alternative that is compliant, it just gets swapped out and everyone carries on as you go with the least expensive option. But the factors that we're considering in the decisions are things like the life cycle cost, the environmental impact, the resident comfort and health, resident interface with the systems in the building, and how it will function in the projected future client, in addition to the upfront cost. So there can be a lot of data to be collected to make informed decisions. And then sort of on the other side of that, a very similar process was done to select the project team. Cost was a factor, but just as important, if not more so, was a value alignment. And next slide.
Yeah, so a little bit more about the project that this is about. FedNor provided the funding for much of the studies and pre-construction. The town of Huntsville also came forward with a piece of property. And so we actually now have had a real project to put these principles to work on. And the team that was put together is very deliberate about stating the values that the team is going to be working on. Who here in construction has had a situation where they felt like they were being blamed for something they didn't do? Oh, that does. So who here's felt like maybe they had a bit of a conflict relationship with somebody, if they're the builder or the architect, if you are the architect, the builder, maybe not listening, communication not working that well, right? So this is a big problem in construction, and we're trying to solve that by actually getting people together early and building trust before the stakes are so high on construction, when there is thousands of dollars being burned every minute that you're trying to solve this problem. Build the trust early, have open communication, set those minimum requirements for behavior towards each other early on in a meeting when the stakes are low. So we practice and we figure out, can we actually work together when the pressure gets a little higher? So being respectful and kind, recognizing that it is kinder to respectfully point out a potential issue or error by a teammate than stay silent and let the project owner, the client, and the other teammates suffer the consequences for that. No room for egos is a theme that comes up a lot when talking about how to de-risk a project. This has to be about the success of the project, and buying in together on the success of the project is absolutely essential. Easier said than done. That's why you spend time doing it before there's hundreds of thousands of dollars of materials being delivered on the wrong day.
Okay, and then we'll just flip over to the building itself. There's a few elements to the design brief, sort of what we wanted the building to be and how we want it to be, and what will it mean to the residents and the community, sort of really subjective characteristics, which sit very nicely alongside some of the, if you go to the next slide, please, the design brief goals that provided by MCLT. So it was fantastic to have a client where the first item on the list was beauty, that they want it to be beautiful, welcoming to Indigenous community members. But in addition to that, they brought in a lot of really useful objective qualities which we can now quantify and put into practice, sort of like high indoor air quality, energy efficiency.
And there was extensive community consultation done to come up with these metrics of what success was going to look like. And one of the other key ones was that pets must be allowed in the building, which leads to sound mitigation issues and other things that are important design criteria that to take into account. But strong direction, clear direction for the design team at the beginning is key in this project.
Okay, the site, I'll just very quickly run through the description of the site. So the site's at Florence Street, West in Huntsville, sort of between Florence Street and Walpole Street on the hillside. It's made up by several parcels of land that are owned by the town of Huntsville, so that explains the odd shape. It's kind of the leftover bits. It's a challenging site. Every time we looked at it, the developable area got smaller. There's one access point. There's areas, a lot of the site is on a really steep slope, which we can't build on. And then there's associated setbacks from the tops of those slopes. In the middle, right in the middle of the site, there's a communication tower with guide wires that are like big tentacles embracing most of the site. So the overall strategy was to develop around a central area, which you could see in the middle of the site. in the middle. So we do need to have a fire route access. So it's not a racetrack, I promise. It's not a racetrack. So yeah, it's just we've sort of dealt with the parking by putting as much as we can in the lower levels of the building, so we don't have to turn over the open areas of the site to a parking lot. We want it to really be a person-centric space. And the town is very kindly relocating the tower to a freestanding tower. So the area that's circled at the top is the location of the original reservoir that supplied the town of Huntsville. So that has been filled in with stuff. So, shudder to think. Shopping carts and bodies. So that we're turning that, it's quite a substantial area space, so that we're turning that over to a community garden. So to be open to the wider community in the area. Next slide, please. And for the central area, because we were able to move the parking either under buildings, in buildings, or off to the sides. So we want to keep the center, which we do need to have the fire route access. But we want to take some of the home zone principles and the idea of a traditional village green. So we're making that area only accessible by emergency vehicles and drop-offs and pickups. So it can be a really outdoor space for the residents and community. Thank you. Sort of the concept that sort of drove the design is the site itself. There's sort of 3 layers to the site. There's the ground, the tree trunks, and then the tree canopy. So we've taken that and applied that to the building just to bring that through. So just something simple, but a little bit decorative, but to really tie it to the place. Next slide. At the entrance of the building, we have kind of an outdoor room that's connected to a common room. So 2 images there. So we just wanted to make it as welcoming as possible for residents and have that as like almost like their lounge or living room coming in off the street. And just some examples of the apartments that we were sort of a typical 1-bedroom. And then next slide, a typical 2-bedroom. We are using CLT for the floors, so we're hoping, depending on that acoustic situation, but our plan is to have the wood exposed in the underside of the ceilings. So just have a really simple material palette and just let the wood sing. Next slide. Oh, and Melinda's going to talk about tails, which was smooth.
All right, back to the quiz at the beginning. So this project has a lot of parameters, design goals and requirements, and one of the key things is that we are going to have a budget that we can't overrun when we get to construction, and we have a not-for-profit that wants to own this building for 100 years and be able to maintain the affordability of those units and the health of those units for that time. So we need to de-risk this project as much as possible from the beginning. And so how do you de-risk a construction project? Back to the question of what's more likely to come in over budget and off schedule and under-deliver a construction of a coal-fired plant or a building. You see, so there's a concept. If you haven't read How Big Things Get Done, I strongly recommend the book. And there's a concept in that book of fat tails and thin tails when you talk about risk analysis. So something with a fat tail has a really wide range of margin, from catastrophic failures to coming in on budget. So the range and possibilities of catastrophic failure has a huge amplification. 5 minutes, okay. And the projects that have thin tails are less risky. The amplification potential of the risk of under-delivering or over-budget or under-delivering is much thinner. And this is from research of thousands and thousands of really big projects. You see at the top, solar and wind projects are some of the lowest risk projects that consistently, over and over again, large megawatt wind power installations and solar deliver on budget, on time, and all the benefits they're meant to deliver. Whereas the Olympics and nuclear storage almost never deliver any of those things. And one of the key distinctions is modularity. Solar installations are repeatable elements. So, we hear a lot about modern methods of construction and offsite construction and modular construction. The win from that, one of the big pieces is that this is a repeatable element. It's not bespoke. You're doing it over and over again, and that de-risks the project. The other piece is that the solar and wind installations, they tend to have teams that are, the same teams do these projects around the world. So these are experienced teams that work together, and they have way of doing things that has delivered, and they know what they're doing. So the Olympics, every time it's a brand new city with entirely bespoke new plans, with an entirely new group of people who have never done this before. Same with nuclear power plants. Everything's completely custom. So, and buildings, understandably, given those criteria, are very risky. And who here has been on a project that came in, took longer than it was supposed to? Nobody? Nobody? Went over budget? Under-delivered in its performance targets? Never. Okay, so we're trying to figure out how to minimize the risk of that. And that's, so modularity, team approach, planning ahead of time. It's so much cheaper to change something when you're all in a Zoom room or in an office. It's so much cheaper than when you have 10 trades on site waiting to be told what to do, charging you by the hour. So that's the goal. Next slide, please.
Melinda kind of covered this. So the major portions of the building will be manufactured off-site, modular, using modern methods of construction. So we're taking advantage of the consistent quality, the reduced waste, and the expedited construction schedule. So some of the consultants that we brought in to this project that you wouldn't maybe necessarily associate with the project, but are absolutely essential to making sure that this project comes in on budget, on schedule, and delivers, is a total cost of building ownership analysis. So that is looking at not just what it costs on day one to construct it, but that plus what it costs to operate and maintain that building over the lifetime of that building. And what is it going to cost to repair it? How often do you have to replace the HVAC system? All of that to figure out, how do we make sure we design it so that there aren't big surprises 5-10 years down the road. Embodied carbon and carbon sequestering analysis. It turns out that the buildings that are most adaptive to climate change and have the lowest total cost of building ownership also tend to have low embodied carbon in them. So we want to measure that as well and know what decisions that we're making informed decisions so that we're not just adapting to climate change, but we're also mitigating and reducing our impact. And in terms of adapting for climate change, we all know it's probably going to get hotter, maybe windier, but what does that really mean? How do I have to attach this building to its foundation so it doesn't get ripped off when the 50-year storms come 3-year storms? What is the engineering spec on that? We may not know for sure, but we have models that can at least give us a good guess so that we're adding a couple extra straps at the design phase early on rather than waiting for those storms to damage the building, cause water infiltration, and have huge headaches down the road. So overheating is going to be a huge problem, and people die when they get overheated. So we need to know what kind of temperatures we're going to be looking at, how long those heat waves are predicted to be lasting, so that we can design the HVAC system today to be able to keep people alive in the building. And our energy model, of course, doing iterative energy modeling with us to help us make good decisions. One more final thought is high-performance buildings can be built at or below the cost of lower performance buildings when higher performance is considered by the design team from the start of a project. And that's a fact. See?
It was in a study, yes, research.
But it is.
A lot of times people say, well, if you're building high performance, if you're building green, it must be more expensive. But that is not the case. That is the case only if you're tacking these things on at the end. When you consider all of these design criteria at the beginning and you have a team that knows what they're doing, we can actually deliver buildings for a lower construction cost and a much, much lower total cost of building ownership. Yay.